Okay, for our third and final video on multi-step inequalities, we're going to look at a few special situations where things that are perhaps unexpected happen. So let's take a look at this first one. We have 10 minus 8a is greater than or equal to 2 times 5 minus 4a. Now, if we go to get a solution for this, there are a couple of ways we can proceed. We can start by using the distributive property here to multiply the 2 by the 5 and then by the negative 4a, or we could divide each side by 2 and neutralize that factor of 2 over here. I'm going to go with the distributive property, so I'm going to multiply 2 by the two terms inside the parentheses. So the left side is going to stay the same because no change is happening there. I still have the same inequality symbol. 2 times 5 is 10, and 4a times 2 is 8a. Now, you're probably looking at this and saying, wait a minute, the two sides are equal, and yes, they're right. So it's a good thing we have a greater than and equal to sign going on here. So we know it's true. So now we're just going to do what we always do. On the right, I'm going to deal with 8a. I'm going to add 8a because I'm subtracting 8a. And I'm going to add 8a. And on the left, I'm going to do that, and on the right, I'm going to do it as well, because the same rules apply as for equations. What you do to one side, you do to the other side. Negative 8a plus 8a gives you nothing on both sides. And so we end up with 10 is greater than and equal to 10. And this is a bit of a head scratcher because we are used to having a solution that looks like this. Variable on one side and a value on the other side with an inequality sign in the middle. We don't have that. We have 10 is greater than and equal to 10. What this means is that the solution set is for any real number. And we can put any real number in there and it's going to be equal. Okay? And some of you probably knew that when you were looking back here and seeing that you have the same thing on the left as you do on the right, 10 minus 8a. It doesn't matter what you put in for a. If you put in the same thing, which you have to, you're going to get the same number. So the solution set here is all real numbers. You could put in 1,000,000, you can put in negative 99, you can put in 2.5. It's all going to be equal. So that's one special solution for inequalities that pops up every now and then. Let's take a look at another. I'm just going to erase a whole bunch of stuff here because I don't want to get rid of my title. Okay, so let's take a look at this one right here. We're going to go 6m minus 5 is greater than 7m plus 7 minus m. Now, take a look at this for a minute and just try to predict what the special solution might be for this one. And now we're going to simplify. Well, the first thing I'm going to do is I am going to take a look on my right side where I have two terms that have the variable m, and I'm going to combine them. So on the right side, 7m minus m gives me 6m, and then I have this plus 7 over here. On the right side, I have 6m minus 5. So let's get rid of our m's. So if I subtract 6m from this side and from this side, I am going to get negative 5 is greater than positive 7. That makes absolutely no sense at all. So what do we do with this? Well, we have to ask ourselves, is it true? Is there any situation where negative 5 is greater than positive 7? And the answer is no, it's never true. It's never true, and so this inequality has no solution at all. We can't graph it, so let's move this over here and get rid of it. We can't graph it. The graph would just be a blank number line because none of those numbers actually work to make this a true inequality. So those are two special solutions that you might run into with inequalities. The first one where all real numbers will work as a solution to make the inequality true. the other where there is no solution at all.